All right, so today we're going to build on this idea of what a function and what a non-function is, and we're going to start to build to an idea of what a linear or non-linear function is. So remember we said that to be a function, essentially x can't repeat. Every input has to have a unique output. So for these first couple, all you're doing is we're going to look at the input and output tables, kind of comparing some equations to some tables. Then we're going to compare with some graphs and start to identify what makes something linear versus nonlinear. So on these first couple, you're going to think back to like when you first learned how to graph and you were given an equation and you made a set of values for x. You substituted them in, and you figured out what the y value was. You then plotted the points, and you got to look at what the graph was. So like on this first one, we have y equals 3x minus 4. And I've given you an input, an x, and then what the output was on the first couple. So like on this first one right here, if you take an input of 1 and you plug it in for x, and we do 3 times 1, which is 3, minus 4, we get this negative 1 that's over here. Okay, same thing for 2. If I substitute in a 2, 3 times 2 is 6, minus 4 gives us 2. Well, that's what it says right here. Okay, so on these next couple, I've given you either x or y, or I've left it blank. So if we look at the next one, I've given you the output. I've given you the y value. So if I substitute that in for y, I have 5 equals 3x minus 4. Okay, if I didn't solve this, I would add 4. So I get 9 equals 3x, divide by 3, and we get x is equal to 3. So right here, I have a 3. Okay, now I have an input of 4. So if I substitute in a 4 for x, we have y equals 3 times 4 minus 4. Well, 3 times 4 gives us 12, minus 4 gives us 8. So when I have an input of 4, I have an output of 8. As you start going, you need to start to look for some patterns. Based on what type of equation it is, you are going to start to discover some different types of patterns. Okay, and it's not always necessarily going to be the same pattern or even the same type of pattern. So if we start to look at this first one, going down the inputs, from 1 to 2, I add 1. 2 to 3, I add 1. 3 to 4, I add 1. So what's probably going to happen for me to get the next one? Well, I should add 1, that gives me 5. I should add 1, that gives me 6. Well, let's see if 614 is correct. So if I take 6 and I plug it in for x, 3 times 6 is 18, minus the 4 does give us 14. So we know our pattern for the inputs is correct. It's plus 1. All right, now we have our outputs. From negative 1 to 2, that goes up 3. 2 to 5 goes up 3. 5 to 8 goes up 3. So my pattern is plus 3 each time. So if I do 8 plus 3, I should have 11, and then 11 plus 3 gives me 14, which is what it has. Okay, so I've got a pattern for my inputs, and I have a pattern for my outputs. What you're going to do for each one of these, some of them say y equals, some of them, like this one down here, says f of x equals, but remember, f of x is just y equals. You're going to do the same thing. If I've given you inputs and outputs, you can substitute in and figure out what the missing values are. Some of them, like on number 3, I started you 1, 2, 3, 4. Well, the next number is 5, 6. Okay, on number 4, I only gave you the 1. Just continue the pattern. 2, 3, 4, 5. Okay, that's what's been happening on all the inputs to give us an idea. Now, on some of these, I do have them out of order, so I don't necessarily have the ordered pairs in order. So you may or may not be able to find a pattern very easily when you look at these. Okay, and then as you get done with these first few, you're going to be asked to identify which ones are linear, which ones are nonlinear, and how do you know? Well, linear means it makes a straight line. There's going to be a way to determine it's a straight line from the equation. There's going to be a way to determine it's a straight line from the table. Okay, and so as you start to work through, that's something that you are going to have to start to try to identify. If you're straight virtual and you never come to class, you may have to do a little bit of like looking up what makes an equation linear, what makes it nonlinear, what makes a table linear versus nonlinear. Because this is going to be something that as we're in class, when we go over this, we're going to build that idea because I want you to try to figure it out without me having to actually tell you. Okay, so on these first few, you're going to complete the table. Figure out the missing points. Then you're going to answer question number 6, which one's linear, which one's nonlinear. Remember, linear means straight line. Nonlinear means a curved line or a line that changes directions. When you get to number 8, I've given you the table. You're going to plot the points. And then similar type of question. Is it linear? Is it nonlinear? How can you tell? How can you tell from the table? How can you tell from the graph? So we're going to start to try to discover those different ideas. For 11, 12, and 13, this is kind of a review of what we've already done. Give me a value that makes it a function. Give me a value that makes it not a function. And then 14, we're going to go the other way around. Starting with number 14, I have given you the table. I want you to match it to the equation. So this is going to kind of start to build on our idea of how do these two things relate. So you may have to look up at those first few questions and go, okay, how could I get from this equation to this table? Because it's easier for me to give you the equation and you to find the table. So compare them. Okay, where might this number have come from? Where did this number come from? Where did these go when I filled them into the equation? Okay, you may end up needing to do some substituting in number 14. You could always take x, substitute it in, see what you get for f of x. Now, a word of caution. Make sure all of your points work. What you'll find is sometimes you'll have a point that will work in a lot of them, but then when you go to the next ordered pair, it won't work. Okay, for example, if I test the point 1 and 4, okay, and I'm trying to see, okay, which equation works? Well, I come down here, 1 plus 3 does give me 4. So I'm like, oh yeah, that works. Well, I come over here, 3 times 1 plus 1, well, that's also 4. Well, they can't have two different equations that represent the same table unless there's a way to turn one of these equations into the other, and there's not. They're totally different. So what you would then have to do is you'd have to try another point. Oh, let me try 2 and 7. Does it work in both of them, or does it now only work in one of them? Typically, once you test 2 points, you will know that the equation matches. And then once you figure out which one matches, you're going to have to figure out how to write that equation without the multiple choice, because starting with number 16, I take away the multiple choice. And you have to write the equation based on what you have figured out in the stuff that we've done so far. Okay, and so for these, starting with numbers 16 through 19, you're going to write the equation without the help of multiple choice. And then for 14 through 19, okay, which one's linear, which one's nonlinear? Try to do it without having to plot the points and graph it and see what you can do. You guys that are virtual, I will post an answer key to this closer to time where you should have it done. So that way you can check and see if what you did was correct. And if you have any questions, just let me know.